Okay, good morning everyone from welding. Alright, so I'm going to begin doing the cube, which is one of the projects from the TIG welding section of the course. So I will get back to doing the forge, but there's a little bit more I've got to get to that isn't so exciting to film, so I'll return back to that once I get it completed. So in the meantime, I'm going to go through the cube and then the dodecahedron. So what I'd like to do is go through this step by step by step, showing you exactly what we are looking for and how to set things up. So this is one that is partially assembled. I'm going to go through this thing from scratch, okay? So first and foremost, we have our parts, all right? So if we look at the parts carefully, okay, these are plasma cut. So what's important to keep in mind is that the plasma cut edges all here and here need to be dealt with, okay? You cannot weld on these just as they are. All right, so this is the top face of the part. It's fairly smooth, but the back face has what's called dross, and that is an edge. If I get close here, that's an edge of burnt steel that is attached to the edge here. Now, now you need to remove this thing. One thing you can do is, of course, grinding, which creates a lot of noise, a lot of dust. You're breathing a lot of stuff. Try avoid grinding unless you absolutely have to do it, okay? Because it's just after hours of that, it gets really fatiguing and it'll wear you out. So the dross is actually not very firmly attached, okay? So if I clamp this down here to the edge of the table with a small clamp, let me see, you can see here. Okay, so you can see right here, just taking a large chisel, it comes off very quickly and leaves nothing behind. Now, that is not everything, okay? After you remove the dross, it's very important to remember that during any kind of thermal cutting process, you're going to be altering the steel, okay? Any heat applied to the steel that melts it is going to change its properties. In this case, you're going to be left with what's called nitriding. So, if you remember, ambient air we breathe is only 21% oxygen, which is what helps us do all the cutting, but the bulk of the remainder is nitrogen. Now, nitrogen, when it is combined with the steel in the heat of the plasma flame, is going to leave what nitride compounds all on the cutting edge to about a depth of between 5 and 10 thousandths of an inch thick. What that basically means is you need to grind away all of that nitrided area where you're going to weld at least half an inch away, okay? Go down to the bare steel, to bright steel. You got to remove this stuff. If you do not remove it from both sides and this edge over here, don't forget that, the face, what will happen is when you try to TIG weld on this, you're going to get a lot of outgassing, bubbling, and instant porosity, and it is a nightmare. You have to remove this from all plasma cut parts. This is very important, okay? And also remember, when you're done with all that, you still have to clean these parts with acetone to remove any surface oils, grime particles that you can't see. That has to be done as well. So this is a very involved process with all 6 parts. They all have to be done the same way, and you have to be very methodical about this thing. A big part of TIG welding is the setup. Setup and cleanliness can take you 80% of the time, and the actual welding maybe 20%. If you do not do that cleaning, if you rush through that, suddenly the welding becomes the 80% part because you're so busy fixing all the mistakes and errors. So this is an important thing. Stick welding, you can plow right through things with impunity. Dirt, grime, rust, paint, whatever. But with TIG welding, we have to take a different approach. You have to think cleanliness, cleanliness, cleanliness. Now, the bench I'm working on here is for steel. If I were going to weld stainless on here, I have a sheet of stainless steel I would put down on top of this to isolate the stainless away from the steel. because what will happen is small particles of carbon steel will embed themselves in the stainless. You'll never see it until it gets wet, and then you'll get little rust blossoms all over the surface. Or they'll get embedded into the weld, and the weld will start to rust. So you got to be real careful about that. For aluminum, same process, but even more so. I'd have a sheet of aluminum on the surface here, and all of my tools would be clean. Grinding wheels, any kind of grinding wheel, cutting wheel, must be only for that metal. So best practice is use new ones every time you work the job. Use a new wheel. You don't know where that thing's been, okay? So if you use aluminum, you got to use grinding wheels, cutting wheels that have only touched aluminum. Stainless, only touch stainless. This is important. Now for carbon steel, of course, you could use anything because carbon steel is very forgiving. It doesn't care. But stainless, aluminum, tungsten, magnesium, any of the exotic alloys, you have to think like you're a surgeon working in an operating theater. This is critical. So I've got some things over here which are very nice. So look over here. So this is the TiG Holder that I made up at the college. And attached to it is a very nice 95-pound magnet that I got at Harbor Freight. This was like $4. It's really cheap. So what this does is, this is very strong, and this will hold this holder in any position I want, holding my torch, and it will not let it fall. So it's a really important thing to make. We have the pattern up at the school. I urge you, make your own. Get a magnet and make yourself a TIG torch holder, because this will save you a lot of agony. When this falls on the ground, okay, these things are not that expensive, but these, the glass ones, however, when these hit the ground, they shatter, and then you're crying. So you want to keep these things, this torch, from hitting the ground. Okay, this is a delicate tool, so a good holder is critical here. Make one, otherwise you're going to be burning through money and being really unhappy about it. Another nice tool we have here are these little, I'm going to be using these magnetic holders right here. These are available all over the place. They're not very expensive. The full kit looks like this, which has a sliding part here which holds parts at 90 degrees to a swivel base. If I take off the 90-degree part, I have this little swivel that's awfully convenient for holding parts in angles for welding or positioning, so I can work on them without having to look for 3 or 4 extra hands, or holding parts at 90 degrees position so I can weld them together. So or tack them together. So it's a very nice little device that is a great labor saver, especially if you're working alone. So these are highly recommended. Grab a couple. They're worth the investment. They're very nice. I have a V-block right here. This is not necessary. A V-block could also be as simple as a piece of angle iron with a base welded onto it so it stays upright. This way I can position parts in the optimum welding angle. Remember we talked about, you always want to position your work in such a way that you're always welding in the easiest position you can. That is, if you remember positions 1, 2, 3, 4 are your basic positions. 1 is easiest, 4 being the hardest, being the level of difficulty. Any chance you can to take your part and move it into the easiest possible welding position, you are saving yourself a whole lot of trouble and working smart. What that means is, if you can, move the part into some sort of a holder or a jig so it positions it in the easiest way to weld it, which also means your weld is going to be really good. The higher level of difficulty means there's a greater chance your weld may have defects and may look really crappy. It's also going to be a lot more exhausting. If you have to do 100 of these things, you don't want to weld each one like it's the finals in the Olympics of welding. You're going to burn yourself out. Don't do it, okay? Just don't. So it's a very nice thing to have. So a piece of angle iron is a really nice thing to make up, a little jig to hold things at 45 degrees. That way you're welding just on the edge. That way I'm not welding this way. I could do that, but you know what? This is a hell of a lot easier. So I'd rather do that. Good chisel for cleaning off dross. This one is a very large chisel. The heavier the chisel you get, the easier it is because you have that mass behind the blade. Okay, if you get some tiny little, honestly, some little homeowner chisel, it's just not going to do the same amount. It's not going to cut as well, do the same amount of work. Get a big one, okay? Maybe hard to find, but big, heavy. This thing's probably 3 or 4 pounds, okay? A light tap and boom, all the stuff comes off with very little effort. So mass is your friend. Get a good one. Okay, I guess I will get things set up. And, oh, one last thing. Okay, your tungsten and your wire. Okay, now when looking at what your weld, say, well, what kind of wire should I use? What is the thickness of your material, okay? Your wire should be no bigger than the thickness of the metal you're welding. So this is 1/16 thickness material, okay? So I want to use a 1/16 wire. If you use a larger size wire, what happens is your base metal is going to melt before the wire does, and that's what happens when you're welding there and you're waiting for your TIG wire to melt into the puddle, and instead it balls up real fast and you get a huge hole in your material. So you want to match the thickness of your wire to the thickness of the material you are welding. In terms of tungstens, you could say, oh, well, you know, maybe I should match the thickness of my tungsten to the thickness of my material. Now, you could do that. Yes, you could use a 1/16 material, but 1/16s are really tiny. And really, if you think about it, if you sharpen the point of a 3/32 or 1/16 tungsten, a point is a point is a point, okay? You're sharpening to a tiny little point. It's the same in the 1/16, except this one has a larger thermal capacity, so it's less likely to melt or overheat on you than the 1/16. So, and anyway, these are a lot easier to sharpen as well. So that's really irrelevant. I like to use 1/16 only for certain really small, really thin pipe welding operations, like 065 wall stainless steel. Then I'll use a 1/16, something really thin, but generally this is a workhorse. It really has to do with the tip, and I like to sharpen these to about 30 degrees. A nice sharp point. You know, some people say to dull off the end, but I've honestly never seen a difference. So don't trouble yourself with that. Okay, so I'll get set up and we will come back after I've done, and I'll grind these and show you what it looks like. Okay, here we go.